Hello everyone, this is Mr. McMillan. I'm here with the instructional video for the last bit of the Pythagorean theorem, which is special right triangles. Now, special right triangles are right triangles that have particular patterns in their side lengths. Okay, so the legs and the hypotenuse have some form of relationship that we can easily use whenever we have one of these special triangles. In comparison to regular normal right triangles, if you have to have a right triangle that isn't one of these special right triangles, then you need two of the sides in order to figure out your third. But for special right triangles, you only need one side, okay? So what we're going to do is try to determine what those patterns are. So let's look at the following triangles. Can you determine a pattern in the side lengths? So the first thing we need to do is determine what exactly our side lengths are. You know, whether we're dealing with the legs, the hypotenuse, you know, what are we dealing with? So in the first triangle here, we see that we have two side lengths given to us, 1 and 1, and then we're missing 1. Well, in this case, we're given both of the legs, right? Remember that the legs touch the right angle. And so the sides that are labeled with 1 both touch the right angle. So we're given both of the legs here. And since they're both the same, it doesn't matter which one we say is A and which one we say is B. Now our other side there is the hypotenuse. It's opposite from the right angle. And it would be equal to the letter C. Okay, remember your hypotenuse is always labeled with the letter C when we do these. So in order to determine the missing side length, C, then we need to take A squared plus B squared equals C squared. Plug in our values and solve for C. So A squared plus B squared becomes 1 squared plus 1 squared equals C squared. 1 squared is 1 plus 1 equals C squared. 1 plus 1 is 2, which equals C squared. Now, just like we talked about in previous videos, you need to make sure that whenever you get to this step, you still have a squared that you need to get rid of from that variable. And you need to do the opposite of squaring a number in order to get rid of it. And the opposite of squaring a number is a square root. So we need to square root the C squared to get rid of the squared. But what we do to one side, we have to do to the other. So we have to take the square root of 2 as well. So that means that C is equal to the square root of 2. The square root of 2 doesn't simplify, so that would be our hypotenuse. Okay, so that's our first triangle. And let's look at our second triangle. So our second triangle, again, we're given both of the legs. So those are our A and B values. And we need to find our hypotenuse. So we have A squared plus B squared equals C squared. A squared plus B squared is 2 squared plus 2 squared equals C squared. 2 squared is 4 plus 4 equals C squared. 4 plus 4 is 8, which equals C squared. And again, we're at this step where we need to get rid of the squared because we're looking for C, not C squared. So we need to take the square root of both sides. And so we get C is equal to the square root of 8. But the square root of 8 can simplify. Okay? So if you remember from previous math classes, you should be able to break down 8 into different factors, and then based on the number of pairs we have, we can pull out numbers in front of the parentheses. So let's look at that. So we have 8 here, and if we break it into 2 factors other than 1 and 8, we can multiply 4 and 2 together. 4 can be broken down further into 2 times 2, and nothing else can be broken down because all the 2's are prime. So we're doing the square root of 8. So we have to have a pair. Well, we do have a pair of 2's that we can bring out. So the square root of 8 is equal to 2. And then we don't have any more pairs. So the only thing left is the 2, and that stays inside the radical. So root 8 is the same as 2 root 2. And if we look at this, in our first triangle, remember anything that's not there in front of a number is considered to be 1, just like 1x, right? So we had 1, 1, and 1 root 2 as our side lengths. For the second triangle, we have 2, 2, and then 2 root 2 as our side lengths. So what do you think we're going to have for the triangle with leg lengths 3 and 3? And so you should be able to see that the pattern is that you have the leg multiplied by root 2. So this should be 3 root 2. And then this should be 4 root 2. And I'm going to show you this one just to verify that it's 3 root 2. And you could do that on your own if you wanted to verify that. So we have a and b as 3. So we have a squared plus b squared equals c squared. 3 squared plus 3 squared equals c squared. 3 squared is 9 plus 9 equals c squared. 18. And then we square root both sides. The square root of 18 can be broken down into 9 and 2. And then the 9 can be broken into 3. We have a pair of 3's, so we can pull this out to 3 root 2. And that's what we got here. Okay. You would be able to verify the same thing for 4 root 2 as well. So the pattern that we have in this diagram, in these diagrams is if the legs of a right triangle are equal, then the hypotenuse equals the leg times root 2. So if the legs of a right triangle are equal, then the hypotenuse equals the leg times root 2. And these special triangles are called 45, 45, 90 triangles. And those 45, 45, 90 refer to the angle measures of the triangle. So we know that the angle measures of these triangles would all be 45, 45, 90 because they all follow this same pattern. And any triangle that has legs that are equal has angle measures 45, 45, 90 if it's a right triangle. Okay, so below we see in a 45, 45, 90 triangle, the length of the hypotenuse is the length of a leg times root 2. So that means that in simple terms, hypotenuse equals leg times root 2. So if we have x on this side here on the bottom leg, then we would also, since it's a 45, 45, 90, the left side has to be labeled the same thing. So x. And then the hypotenuse is x root 2, since it equals the leg times root 2. And x can be any positive number, okay? Now, on the other hand, if you are only given the hypotenuse and you want to determine the leg, then you need to solve for the leg. You would divide both sides by root 2, and so you would get your leg equals the hypotenuse over root 2. Okay. So it just depends on which one you have. If you have the legs already, just multiply by √2 to get your hypotenuse. If you have your hypotenuse, on the other hand, you need to divide by √2. All right, now let's consider the following scenario. Let triangle ABC be an equilateral triangle with perpendicular angle bisector BD, which intersects AC. Consider each side length of triangle ABC to be 2 meters. So over here we have an equilateral triangle where each side is 2 meters. Okay. So how many triangles are formed in this scenario? What would the length of BD be? AD, DC? So we're trying to find our missing links for the triangles that we have. And because we have a perpendicular bisector here, we see that it splits the triangle into 2 halves. Okay, so it splits into 2 halves. And since this is a bisector, remember that bisect means to cut in half. So this cuts this in half. So this side length was originally 2. So AD and DC would both be half of 2, which is 1. So now we're only missing the side length for BD. And since these both are right triangles and we have 2 sides, we can determine what BD is, okay? And the important thing is that if it helps, cover up one of the triangles so you have less to look at here. So what sides do we have? Do we have a leg and a hypotenuse, or do we have 2 legs? Well, if we look here, we see that the side opposite from the right angle is labeled with a 2. So that would be our C value. That is our hypotenuse. Our short leg is 1, so we're going to label that with an A. And our missing side we're going to label with B. Now, using the Pythagorean theorem, we find A squared plus B squared equals C squared. So A squared would be 1 squared. We don't know what B is, and then C squared would be 2 squared. 1 squared is 1, plus B squared equals 4. Now we need the B squared by itself, so we need to get rid of this 1 by subtracting it from both sides, and we get B squared equals 3. And then we square root both sides to get rid of the squared, and that is B equals √3. Okay. Now, let's talk about the angle measures of these right triangles here. So since this was an equilateral triangle, remember equilateral triangles have the same angle measures and all 3 sides are the same. So if this is an equilateral triangle and the sum of the angles in a triangle is 180, A, B, and C all have to be 60 degrees because we have to take 180 and divide it by 3. So all of these angles are 60 degrees. And since this was a bisector, if this was 60 degrees, then each of these parts would be 30. So if you have this pattern, you are dealing with a 30, 60, 90 triangle. Okay. So anytime you have an equilateral triangle that's folded in half, it follows this pattern. The short leg is the base, and then you would have the long leg be equal to whatever the short leg times √3 is, and the hypotenuse would be double the length of the short leg. Okay. So formally stating that, in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, okay? So the hypotenuse is equal to 2 times whatever the short leg is. And then the longer leg is the length of the shorter leg times root 3. So the long leg equals the short leg times root 3. So as you can see, the short leg forms the basis for both of these calculations. If you don't know the short leg right at the start, then that's the first one you need to find in a 30, 60, 90 triangle. Okay, so over here on this side, if I have x on my short side, and the short side would be on the left side here, then my hypotenuse is equal to 2 times the short leg. So it would be 2 times whatever x is. So our hypotenuse would be 2x. And then our long leg would be the short leg times root 3. So our long leg would be x times root 3. Okay. And again, if you want to find the short leg, for this, if you have the hypotenuse already, you're going to have to divide it by 2 to find your short leg. So the short leg is equal to the hypotenuse divided by 2. As you can see here, if we divided 2x by 2, we would just get x. Same thing here, except instead of dividing by 2, we're going to divide the long leg by root 3. Okay. All right, so let's look at some example problems on the next page. Okay. So let's look at the first one. It says we want to find the missing side lengths and leave our answers as radicals in simplest form. Now, when you do this, you need to make sure you can identify which type of triangle you have first, whether you have a 45, 45, 90 degree triangle or a 30, 60, 90 degree triangle. So let's look at number 1. Number 1, do we have a 45, 45, 90 or a 30, 60, 90? Well, the 45 degree angle in here gives it away that we're dealing with a 45, 45, 90 triangle. Okay. Well, we're given one of the side lengths already, and we want to find what x and y are. Well, the side length we're already given is 20. And is that a leg or is it the hypotenuse? Well, the side that has a 20 labeled on it is touching the right angle. So that means that our leg is equal to 20. Okay. Well, since this is a 45, 45, 90 triangle, we know that the legs have to be equal to one another. So that means that our other leg, which is labeled with a y, would also have to be equal to 20 because they have to be the exact same thing. So y equals 20. So now we're looking to find x. Well, x is the hypotenuse, and our hypotenuse rule for 45, 45, 90 triangles is that the hypotenuse is equal to the leg times root 2. Well, our hypotenuse is labeled with an x. So x equals the leg length, which is 20, times root 2. And so those are our two two missing side lengths. Okay. So the legs are equal in a 45, 45, 90 triangle, and the hypotenuse is equal to the leg times root 2. Now let's look at number 2. Now in number 2, we have our triangle here, and is this a 45, 45, 90 or a 30, 60, 90? Well, since we have a 30-degree angle here, we know that we have a 30, 60, 90 triangle. Now, are we given the short leg, the long leg, or the hypotenuse? And if we look here, we see that we're given the long leg because the side opposite from 60 degrees is what is labeled. So our long leg is equal to 10 root 3. So if you remember, I told you that you would probably need to find the short leg first, your short leg first, if you had your long leg or your hypotenuse first. So our formula for the long leg to start with was the long leg equaled the short leg times root 3. Well, our long leg is 10 root 3. Our short leg is the letter N times root 3. Now, it should be quite obvious here that the only value that N could be is 10. Okay? The only value that N could be is 10. So, if we wanted to solve this like a normal equation, we see that we have N times root 3. So in order to get rid of that root 3, we would need to divide it on both sides. And we would see that the root 3's cancel over here, leaving us with 10 equals N. So now that we have our short leg, we can find out what our hypotenuse is rather easily. So our formula is hypotenuse equals the short leg times 2. Our hypotenuse is M. Short leg is 10 times 2 would be 20. So N equals 10 and M equals 20. All right, number 3. If we look in number 3, we see that we have a 45, 45, 90 triangle because we have a 45-degree angle here, which makes this one the same. Now you'll notice instead of being like number 1 where we had a leg given to us, this time we have a hypotenuse given to us. The side opposite from the right angle is labeled with a value. Now, since this is a 45, 45, 90 triangle, we know that M and N both have to be the same value because the legs are equal. So since the legs are equal, we know that M is equal to N. But how are we going to find the leg? Well, our normal equation is hypotenuse equals the leg times root 2. Now we know our hypotenuse, which is 14 root 2. We don't know what our leg is. We know it's one of these, or we know that we could say either M or N, so I'm just going to say M. And then times root 2. Well, if I want to solve for M, well, what do I need to do? Well, it should be quite obvious that M should be equal to 14, but if it's not, go ahead and divide that by root 2. And you should see that M is equal to 14 because the root 2's cancel on both sides, and you just end up with 14. Then, since this is a 45, 45, 90 triangle, N would also be equal to 14. All right, number 4. Number 4, we're dealing with a 30, 60, 90 triangle, because we have a 30-degree angle, which would make this 60. And unlike in number 2, this time the side that's opposite 30 degrees is labeled, so we have the short leg being equal to 2 root 3. So now we need to find our long leg and our hypotenuse. Most people prefer to find the hypotenuse first, then the long leg, because since we have the short leg, we can easily find both of those with no real hassle. So the hypotenuse is equal to the short leg times 2. Well, our hypotenuse is labeled with the letter X. Our short leg is 2 root 3 times 2. Now, since we have both a coefficient in front of the root 3 and not a radical here, what's going to happen is the 2 is going to get multiplied by the 2 outside the radical. So 2 root 3 times 2 becomes 4 root 3. So our hypotenuse is 4 root 3. Now we're going to find our long side. So the long side is equal to the short side times root 3. The long side is labeled as y. Our short side is 2 root 3, and then times root 3. Now, if you type this into Desmos, and I'm going to go to Desmos real quick just to show you. If you type that into Desmos, you're going to put 2, I'm going to put parentheses just in case, and then times square root of 3, and you get 6. The reason that this happens is because 2 root 3 times root 3, the root 3 times root 3 becomes root 3 squared, so this just becomes 2 times 3. So this is y equals 6, so our long side is y, or our long side is 6. All right. Number 5. Number 5, we see that we have a 60-degree angle in a right triangle, so we are dealing with a 30, 60, 90 triangle in this case. So what we need to do, we need to figure out what side we have right now. And the side that we have right now is the hypotenuse because it's opposite the right angle. So our hypotenuse is equal to 9. So since we're dealing with the 30, 60, 90, we need to find our short side first. And to find our short side, we know that the hypotenuse is equal to the short side times 2. Our hypotenuse is 9. Our short side is y, and times 2. Then we'll divide both sides by 2 to get y by itself, and we find that y is equal to 9/2. Okay. Now, since we have our short side, we can find our long side. So our long side is equal to the short side times root 3. Our long side is labeled with an X. Our short side we just found to be 9/2, and then we're going to multiply by root 3. Now, while you can keep that like it is, this is how it's preferred to be written, okay? So this, when we say 9/2 times root 3, this is basically 9/2 times root 3 over 1. And when you multiply fractions, you multiply straight across. So this is going to become x equals 9 root 3 over 2. So that is what your long side is equal to. Okay? All right, let's look at number 6. Now, number 6 is a little bit more tricky, but that's because of the side length that we're given. So we have a 45, 45, 90 triangle here. Gives it away because it gives us a 45 degree. And what we're given in this case is one of the legs. So we know that the leg is equal to root 6. Well, since we're dealing with a 45, 45, 90 triangle, we also know the measure of the other leg. which would also be root 6 because the legs are equal. So the legs are equal, and the other leg is given by the letter B. I apologize for that. Okay. So B equals root 6. So now we need to find our hypotenuse. Okay. And our hypotenuse is A. And in order to find the hypotenuse, we need to take the leg and multiply it by root 2. Okay. Now this is where it's going to get a little complicated. Our hypotenuse is A. Our leg has a value of root 6. And then times root 2. Now when you multiply radicals together, if they have the same base for the radical, so in this case they both have the same base because they're both square roots, you can multiply whatever's inside of the radicals and just put it underneath one of them. So here, square root of 6 times the square root of 2 would be the square root of 6 times 2. So that means A is equal to root 12. Okay. Now A is equal to root 12, but that radical can be simplified. So if we take 12, we can split it into 4 and 3, and we can split 2 into 2 and 2. So then we can pull out a pair of 2's, and then our radical here would have a 3 left underneath it. Now, if you see something like this on IXL, you need to make sure that that's what you're doing. It wants you to simplify those radicals, okay? So if you do see something like that, make sure that you do that. All right, let's look at number 7. All right, so number 7, sorry about that, I had a phone call. So number 7, we have a 45, 45, 90 triangle as well. And if we look here, we can tell that we don't have our hypotenuse, but we do have a leg. And our leg is equal to 9 root 2. Okay, so our leg is 9 root 2. And since this is a 45, 45, 90, we know we know that the legs have to be equal. So we know that our other leg also has to be 9 root 2. So in this case, y is our other leg. It touches the right angle. So y has to be 9 root 2. Now we need to find our hypotenuse, and our formula for finding the hypotenuse is hypotenuse equals leg times root 2. So our hypotenuse is x, our leg is 9 root 2, and then we have to multiply 2, or multiply root 2, excuse me. Okay, if you type this into Desmos or into your calculator, if you take 9 root 2 and multiply root 2, you're going to end up with 9 times 2, which is 18. Okay, so x equals 18. The reason for this is this becomes the square root of 4, and the square root of 4 is 2, and 9 times 2 is 18. All right, number 8. Number 8, we have a 30, 60, 90 triangle. And we see that the side opposite from the 30-degree angle is marked. So we have our short leg, which is 8. Okay, so our short leg is 8. So since we have our short leg, we can just immediately go into finding the other legs, or the other measures. So most people like to start out with the hypotenuse. So our formula is hypotenuse equals the the short leg times 2. Our hypotenuse is A, and our short leg is 8, and then we multiply by 2. So A is equal to 8 times 2, which is 16. Then if we look at B, B is our long leg. So long leg is equal to the short leg times root 3. Our long leg is B. Our short leg is 8 times root 3. So B is 8 root 3. Okay. What I would like you to do is I would like you to try the other 4 that's on this page on your own, see if you can do those, and then check through the video after that to make sure that you got those correct and understand what you need to do. All right, so let's look at number 9. Number 9, we have a 30, 60, 90 triangle. And we see that we have the long leg labeled here, which is equal to 3 root 3. So with these situations, we need to find the short leg first before we find anything else. So we know that the formula that deals with long legs is long leg equals the short leg times root 3. Our long leg is 3 root 3. Our short leg is n, and then times root 3. So we can see that n would have to be equal to 3, and you can verify that by just dividing by root 3 and getting that n is equal to 3. So now that we have our short leg, we can find our hypotenuse. Our hypotenuse is equal to the short leg times 2. So our hypotenuse, which is m, is equal to 3 times 2, which is 6. Number 10, we have a 45, 45, 90 triangle. In our 45, 45, 90 triangle, we know that we have a leg here because it touches the right angle. And we know since we have a 45, 45, 90 triangle, the legs have to be equal. So y has to be 3 root 2. Now to find our hypotenuse, our formula is hypotenuse equals leg times root 2. Our hypotenuse is x. Our leg is 3 root 2. And then times root 2. So 3 root 2 times root 2. If you type that into Desmos, that should have given you 6. Number 11. Number 11, we have a 30, 60, 90 triangle. 30, 60, 90 triangle. And in this case, we're given the hypotenuse as our initial side. So since this is a 30, 60, 90 triangle, we need to find the short side first. So we know that the hypotenuse is equal to the short side times 2. So hypotenuse is 12. The short side is labeled as y, and then times 2. Divide both sides by 2, and we end up with 6 equals y. So our short side is 6. Now that we have our short side, we can figure out our long side. So the long side is equal to the short side times root 3. Our long side is labeled as x. Our short side is 6, and then times root 3. So x equals 6 root 3. And finally, number 12, we're dealing with a 45, 45, 90 triangle. In this case, we're given the hypotenuse, and we need to find both of the legs. All we need to do is find either A or B, and we know that they're equal. So our hypotenuse is equal to the leg times root 2. Our hypotenuse in this case is 3 root 2. Our leg is either A or B, and then times root 2. A should be equal to 3. It should be very clear from that. But if you divide both sides by root 2, those cancel out and you end up getting 3 equals A. So 3 is also equal to B. And that does it for this video on 45, 45, 90 triangles and 30, 60, 90 triangles. So please make sure that you're working on the iExcel. I also have a worksheet that I give that will serve as some additional review over the Pythagorean theorem, as well as the special right triangles that we just went over. Those are questions similar to what you would see on a quiz or a test. Okay, that's what we'll be doing tomorrow in the Zoom on January 15th. So please make sure that you join those. And if you have any questions, please make sure that you ask questions, because otherwise we're not going to be able to help you if we don't know where you're struggling. Okay, so just work on those. The assignment on these is Q.4 to a minimum of 60. Thanks, guys, and I will see you in the next video.